here we shall see what are the Fourier sine and cosine transforms. So firstly let me define what is a Fourier cosine transform. Fourier cosine transform. If your function f of t is defined as this, so this is defined like this: capital Fc of omega, that is equal to the Fourier transform, cosine Fourier transform of the function f of t. This is given by integration from 0 to infinity f of t cos omega t dt. So this is the definition of Fourier cosine transform. What is this? This is integration from 0 to infinity f of t cos omega t dt, right? So, or you can write this to be the Fourier transform, Fourier cosine transform of the function f of t, that is equivalent to the Fourier transform of this function fc of omega. So now we can compare this, we can compare it with the Fourier cosine integral representation. What is this? As we have written the Fourier integral representation for the given function, similarly we have Fourier cosine integral representation and Fourier sine representation. So when you compare it with this, what is this? It is whenever your function f of t, that is defined by 1 by pi integration from 0 to infinity a of omega cos of omega t d omega, where what is this a omega? A omega is defined by 2 integration from 0 to infinity f of t cos omega t dt. So this is the Fourier cosine representation. Now we can compare these two. So when you compare these two, from here you get 2fc omega, that is equal to a omega. How? Because what is a omega? A omega is this quantity, and what is this quantity? This quantity is nothing but fc omega. So from here on comparing, you get 2fc omega is equal to a omega. So that means from here we can also derive the inverse Fourier cosine transformation, that is defined by the function f of t, that is given by 1 by pi integration from 0 to infinity of 2 fc omega cos omega t d omega. How this is obtained? This is obtained when you substitute the value of a omega as 2 fc omega. So this is the formula for forward Fourier cosine transform, forward Fourier cosine transform. So that means whenever you have the given function f of t, you wanted to calculate its Fourier cosine transform in the frequency domain, and if you have the coefficients in the frequency domain fc omega and we wanted to calculate what is this ft, so for that purpose we have the inverse Fourier transform formula. So let us have a look at one question. So the question here is, find the Fourier cosine transformation of the given function f of t, where f of t, that is defined as t in the interval 0 to L, and it is 0 whenever t is greater than L. So this is given to us. We are to calculate what is its Fourier cosine transform. So for Fourier cosine transform, we know the formula. The Fourier cosine transform of the function f of t, this is defined as integration from 0 to infinity f of t cos omega t dt. So this is equivalent to, here what we can do, we have to solve this integration. So for that we will substitute the values of f of t. What is the value of f of t? I am sorry, here it should be t. It is given to be t here in the question. So in the interval from 0 to L, the value is t. From t greater than L, it is 0. And we have our interval from 0 to infinity. So that means we can break it from 0 to L. So the function's value is t cos omega t dt. And from L to infinity, the value of function is 0. So 0 into cos omega t dt. Right. So this this is the value. So this term is obviously 0. The integration of 0 is 0. So here we will perform the integration. So this is the first term. This is the second term. First term as such, the integration of second would be cos omega t divided by omega, and we will substitute the limits from 0 to L, minus integration from 0 to L, the derivative of first term, that is 1, integration of second term, that is sine omega t divided by omega dt. So when you substitute L here, so it would be L divided by omega into sine omega L, and then when you substitute 0 here, it would be 0. And then what is the integration of sine omega t? It would be cos omega t divided by omega. So here minus and minus, that will become plus. So cos omega t divided by omega square, because 1 omega was already present. So here we would have L divided by omega sine of omega L, and here it would be 1 by omega square cos omega L minus cos of 0. Cos of 0 is 1. So simply this is the representation of the given function in the Fourier cosine transformation after applying the Fourier cosine transformation. So let us now next see what is the Fourier sine transformation of the given function. Fourier sine transformation of f of t, some function f of t. So this is defined using the expression fs of omega, that is equal to the Fourier sine transform of the function f of t, which is defined again from the interval 0 to infinity, f of t sine omega t dt. So this is the forward Fourier sine transform of the function. That means we have shifted our function from f of t to some other function in this frequency domain. So now for coming back from here to here, what we have to do, we have to apply the inverse Fourier transform onto this particular function. So we can compare this function with the Fourier sine integral transformation. So what is it? The function f of t is defined like this: 1 by pi integration from 0 to infinity b of omega sine omega t dt, where what is this b omega? The coefficient b omega, they are defined using this formula to integration from 0 to infinity f of t sine omega t dt. So now we can compare this b omega and fs omega. So now the value of this one is this, which is similar to this one. So we can write b omega is equal to 2 times of fs omega. So we can substitute this value of b omega over here. So we would have f of t is equal to 1 by pi integration from 0 to infinity to fs omega sine omega t dt. So this is the formula for inverse Fourier sine transform. So we have these two formulas. One is for calculating the Fourier sine transform, and we have another formula. This one is for calculating the Fourier sine transform, and for the inverse Fourier sine transform we have this particular formula. So let us see one last example question related to this one. Question says find the Fourier sine transform of f of t, which is equal to t and 0 for this interval 0 to L and t greater than L. So the solution here is, for calculating the Fourier sine transform, we will apply the formula. That means we will apply the Fourier sine transform on the given function. So according to this formula, we have integration from 0 to infinity of the function f of t sine omega t dt. So again we will break this interval from 0 to L. From 0 to L, the function's value is t, so we have t sine omega t dt, and from L to infinity your function's value is 0, so you have 0 into sine omega t dt. So now this term would obviously be 0, so again here we can apply by parts for integrating it. So first function as such, the integration of second would be minus cos omega t divided by omega, and the limits from 0 to L, and then minus integration from 0 to L, derivative of first function would be 1, the integration of second function would be minus cos omega t divided by omega into dt. So we can simplify this. When you substitute L, you would be having minus L by omega cos omega L, and then when you substitute 0, so you would have 0 here, and this minus and minus becomes plus, and then what is the integration of this cos omega t? It would be sine omega t divided by omega square, limits vary from 0 to L. So we would have at the end minus L upon omega cos omega L plus 1 by omega square sine omega L, and sine of 0 is obviously 0. So the final answer is minus L upon omega cos omega L plus 1 by omega square sine omega L. So this is the final answer, and this is the Fourier sine transform. This is the Fourier sine transform of the given function f of t. So I hope this is clear to you.